Hi guys, this is a video demonstration of assignment 3 for CSCI 572 Information Retrieval and Web Search Engines under Professor Chris Matman at the University of Southern California. The objective of this assignment is to visualize and interact with NSF and NASA Polar datasets. For this purpose, we have used D3.js, Facet View and Banana. This is the main web interface of our assignment and all the three visualizations have been linked to this page. We have taken a subset of around 40,000 documents out of the given dataset to visualize the data. Now, I am going to show you all the 4 queries one by one in D3.js. So, this is the first query. The first query require us to find the time-based trends that exist for distribution of oil, iron and other natural resources in the Arctic region. We have used spatial data in combination with temporal data to show time-to-time variance in the presence of oil, iron and other natural resources over the Arctic region. For spatial data, map was used, and for temporal data we have used animations to depict the increase and or decrease in the number of relevant documents in a particular region. Now, in this visualization, every second is mapped onto one date, and as the animation runs, you can see the new documents are found in different places like District of Columbia, New Jersey, New York, etc. Now, we have used different colors like green for others, natural resources, blue for oil and red for iron. So, these 3 colors basically depict all the different natural resources found in a particular region. Now, when we hover on a particular region like Northwest Territories, we can see the name of the region and also the kind of natural resources found at that region. For example, if we select something like Colorado, we can see there are 5 relevant documents regarding oil in Colorado. So yeah, this was the first query. Now we are going to see how the second query is visualized. For the second query, we had to show the regions where the relevant documents were found. Here, we used a color scheme to depict the various regions of interest. A light shade in the color scheme is used for places with less number of data, whereas a darker color in the scheme is used for depicting regions with a lot of data. For example, you can see this is the Northwest Territories. So here, the number is 3, the document count is 3, whereas when you check California, it's 14. So because this is there's more document in California, that's why it's been colored in a darker shade. We have also provided 4 buttons over here to show 4 different dates. Now these dates were chosen as they showed a marked difference in the relevant data. Now I can just change the dates over here and you can see how the visualization is changing. Okay, so now as seen on the visualization, there's data in the US region, there's data in the Arctic region, in Australia, etc. Also, on the bottom right of the screen, we have this bar graph over here. What's happening is this bar graph is displaying the different regions and their cumulative document score in all the dates. For example, if I select New Jersey, it's showing 94. This means that this is the total document score across in New Jersey for all the given dates. Another thing to notice over here is if I hover on any region of interest, the visualization shows me the region name as well as the document count. For example, if I select Idaho, it shows me the name of the region, that's Idaho, and the document count, that's 12. Now for the third query, we had to predict areas of national security interest. So we have used a circle packing widget to display the query results. In this, the smaller blue circles represent regions. So if I hover, I can see the name of the region, Florida, Idaho, then this Missouri, etc. Now, such a circle with bigger radius corresponds to a place where there is more amount of national security compared to other places. Now, inside the blue circle, there are various smaller orange circles. Now, these circles are the actual national security interests like air, sea, land, etc. Okay, so now I am going to go ahead with the fourth query. The fourth query required us to identify trends with respect to science data and measurements related to climate change. So here we have used pie chart widget, bubble chart widget, and maps for displaying the results. Now the spatial data is depicted using maps, whereas a bubble chart is used for depicting the relevant documents found in the regions over here. Now the circle in the regions of interest have radius proportional to the amount of documents related to sea ice extent and decline found in those regions. So for example, if I hover on this region of interest, Massachusetts, you can see the circle is quite big compared to the circle over here. Like California, it's only 14 and here it was around 30. So yeah, that's why the circle has a smaller radius. We have also shown, given the option to change the dates, we have provided 4 radio buttons. So you can select 4 different dates and then visualize the data. Also on the right of the screen, there's a pie chart. Now this pie chart shows cumulative document counts across states. So there's Massachusetts, there's Mississippi, etc. So this is basically the amount of data contained in a particular region of interest for all the possible dates given on the left of the screen. So again, you can see that when I hover, I can see the region name as well as the document count for that particular region. So yeah, so this completes our D3. Now I can move on to facet view. So the results you can see here are the tag documents, which are about 40,000 in count. You can see over here, and they are shown they're shown 50 at a time. 50 counts are shown at a time. Now in facet view, we get a very organized view of the relevant data. The data is put into buckets based on different categories. We have differentiated the data based on features like date, location, as well as title. You can see title over here, you can see location over here, and you can see date over here. You can also use facet view to collapse or expand a particular feature. Okay. So now suppose you want to view regions of interest covered by ice, then I can simply type ice over here. As you can see, these are the relevant documents found for ice. So there's a count of 7,684. So these are the valid documents. Now these results are categorized according to the different dates and locations in the data. So I can just, select something like this, and over here you can filter the search results. Okay, so you can later filter it using location, or vice versa. You can select location first, you can select and then select date. So you will get different results based on the filters that you're using. Okay, so now I'm going to go back and show how banana works. Okay, so now I am going to shift my focus to banana. We found the interface of banana to be very user friendly and appealing. With a few clicks we could easily add panels to visualize the entire data. We have used 3 panels over here. The first panel is used for visualizing the entire distribution of data in the different regions. Here a color scheme is being used. So a darker color in the scheme is used for showing those regions where there's more amount of data, whereas a lighter color in the scheme is used for showing those documents where there's lesser amount of data. For example, China, there's only 4 valid records, whereas in United States of America there's a lot of data. So you can see the change right here. Now the second panel is the tag cloud panel. Now what this panel does is it takes as an input a field based on which it creates an inverted index, and then the values with the highest TF-IDF are displayed. So these are the values with the highest TF-IDF. For example, there's global, there's master, there's variable, there's directory, etc. Now I'm going to show you the third panel. The third panel is a pie chart which basically segregates the documents, all the documents on the basis of location and displays them in different colors in a pie chart. Now over here you can see US, then there's Denmark, then there's Russia, etc. So all the locations are shown over here with different colors, and also the percentage of the documents found over here. If I hover on a part of the pie chart, what I can see is the region as well as the document count. Now I am going to input a query over here. So suppose I type in climate change and I press enter. You can see that the visualization changed, it got updated and now is showing the relevant documents for the query terms climate change. Again, the color scheme is being used over here to show regions of interest with different amounts of data in them. Also the tag cloud got updated, and these are the values with the highest TF-IDF. Again, the pie chart is also updated, so we can see the different locations and also the count of their documents. So this ends all the visualizations for our assignment 3. I hope you enjoyed watching our video. Thank you so much.